A very good morning to all. Welcome to another session on 5G or 4G cellular systems. We had seen two sessions previously. If there are any queries in the previous two sessions, you can kindly type in chat box. I'll wait for another 5 or 6 minutes. Then we'll start today's session on drivers for long-term evolution. I'll give you a recap of the drivers. Then we'll proceed on to the standardization of LTE. Okay, we'll start today's session on the drivers for LTE. The evolution of the 3G systems into the 4G systems was driven by the creation and development of new services as provided for new mobile that was being evolved into the existing systems. So that led to the technology to drive towards LTE. This was enabled by the advancement of the technology which was available for mobile systems. So this evolution in terms of mobile technologies, in terms of requirement for efficient spectrum usage, deployment of new devices, all led to the driving factors of LTE, which we had seen. And the biggest driving technology for LTE to come into existence was the higher data rate support, minimized delay in accession of signals, and the capacity utilization. The demand for new services in order to provide higher peak data rates, higher peak bit rates, the demand for more spectral resource utilization, and in order to beat the existing competitors, the mobile operators found an alternative technologies with the existing mobile broadband. So all this came into as a combined future for evolution towards the long-term evolution, which we call it as LTE. So for that they have developed GSM. So the GSM was extended to some additional features called as GPRS, Edge, and WCDMA, but they were still using circuit switched domains during the 1990s. So later, the later on developments made an system or a module called a system architecture evolution, which was initiated during the development of LTE, and that resulted in the evolved packet core structure to support HSPA and the LTE Advanced. So all these things we had discussed in the previous class. So in today's session, we'll be seeing how this LTE was standardized. So the standardization of long-term evolution. With a framework for IMT systems, it was set up by the International Telecommunication Union with the spectrum made available by all over the world. The task of specifying the LTE system was in the hand of the 3GPP system or 3GP third generation partnership project members. They were responsible for developing this LTE. So they write the specifications for 2G, 3G, and 4G mobile systems, and the specifications written by them are being widely deployed in the world, where around 4.5 billion connections was given in the year 2010 due to the development of the 3GPP. So in order to understand how the 3GPP works, it is important to understand the process of writing standards. So what are the writing standards is that writing standards for any architecture or for any system to develop depends upon its standard. So first, the 3GPP requirements. What are the requirements that they require? Like the higher data rate, lower cost, less complexity, efficient spectrum utilization. All these requirements would be noted down. So those are the requirements. So for that requirements, an efficient architecture is being developed depending upon the requirements. Okay. Then if the architecture is being developed, the next process is to check its specifications. Check its specification whether this specification would meet the standardized goal, whether this specification would be appropriate for the design. So that will be checked up. So then it is sent for testing and verification. It is sent for the next phase called testing and verification. The developed architecture, if it meets the given requirements, then it passes, or else the specifications are being checked, and if the specifications are not met, then the architecture is being checked. If the architecture is not done properly according to the requirements, then the requirements, according to the requirements, it is being modified. So this process goes on until a defined system is being proposed according to the requirements. Everything is based on the requirements. So that requirements will vary depending upon the application that is being done, which is the work of the 3GPP. So the procedures which I had shown you in the diagram, the requirements, the standardization process is different in different forums. First one is the requirement, where it is decided what is to be achieved by the standard. Next is the architecture, where the main building blocks and the interfaces are being decided. Then the detailed specifications, where every interface is specified in detail. After that, the testing and verification, where the interface specifications are proven to work with real life equipment. If there is any variation, accordingly the specifications architecture will vary. And normally it will take around 1 or 2 years and the standard is complete. For example, if today I am completing a project or if I'm completing a standard which I had developed, it will take at least 1 or 2 years such that it comes out as a commercial product. So, at least 2 years of standardization. When it is approved, it will come out in market immediately. So design stands a major constraint. So designing an LTE and standardization is a very much difficult task for the researchers, for the scientists, those who are working in 3G PP. So third generation partnership project, in short 3G PP we call it as. This is the standard standard developing body that specifies the LTE or the LTE Advanced along with the 3G, Ultra and 2G GSM systems. This is a partnership project formed by the standard bodies ETSI, ARIB, TTC, TTA, CCSA and ATIS. This consists of four technical specification groups, TSGs, we call it in short as technical specification groups, which is a parallel partnership project called 3G PP2 was formed in 1999. So this also developed the 3G specifications, but it was meant only for CDMA 2000. That is, what is the CDMA 2000 is that this 3G technology developed from second generation CDMA based system. It was working on IS interim standard 95, IS 95. Then the 3GPP third generation partnership project, the technical specification group called RAN, Radio Access Network, is the technical specification group that developed the wideband code division multiple access, which we call it as WCDMA, which is the evolution of HSPA as well as the LTE or the LTA Advanced, which we are going to see. So the development of the LTE and the LTE Advanced was done by only this RAN group, Radio Access Network Technical Specification Group, so which is being classified into 5 groups. You can see radio layer 1, WG1, radio layer 2 and layer 3, RR, WG2, working group. WG represents working group. Then WG3, it is LUB, LUC, LUR and Utron GSM requirements. Then WG4, radio performance and protocol aspects. WG5, mobile terminal conformance test. So this is the technical specification group of the radio access network. You can see which is highlighted in white. The remaining other groups that were being presented along with the 3GGP, 3GPP is being charted here with the partnership project coordination groups, PCG. So the technical specification group of radio access network RAN is classified or consists of 5 working groups: WG1, WG2, WG3, WG4, WG5. Each and every group is responsible for some of these specification standardizations. What is this WG1 dealing with? What is its function? It deals with the physical layer specifications. WG2 deals with the layer 2 and layer 3 radio interface specifications of the OSI model. WG3 deals with the fixed RAN interfaces, for example, interface between nodes into the RAM, and the interface between the RAM and the core network. So that work is being carried out by WG3. WG4 deals with the radio frequency and radio resource management performance requirements. Performance of the radio frequency and the radio resource management, RF and RRN. Then the WG5 deals with the conformal testing. Whatever 1, 2, 3, 4 does, they test, they develop, they test the developed thing, then they give conformance whether this is working or not, whether this can be sent as a product or not. So the scope of this 3GPP was formed in 1998, and it was to produce a global specifications for the 3G mobile system based on evolved GSM core network that included the WCDMA based radio access of the Utron FDD and the TDMA TD CDMA based radio access of Utah TDD mode. So the task was to maintain and develop the GSM or edge specification that was added to the 3GPP, and now that is given as EUTRA. Okay, EUTRA. Previously we had seen UTRA. Now the GSM or the edge standard is added with the 3GPP systems, which is called as EUTRA. So the EUTRA we'll see in detail in the next presentation. Okay, what is EUTRA? So let us see how this 3GPP specifications was being released. The releases for 3GPP. The release 8 was given in December 2008, which was the first release for Evolved Packet Core of the System Architecture Evolution, which is considered as the first release. In 2009 December, the LTE Home Node B, long-term evaluation Home Node B, which supported location services, mobile broadband mobility service support, multi-standard base station, was released in release 9, the year December 2009. In March 2011, the carrier aggregation along with the enhanced downlink multiple input, multiple output MIMO structure. This uplink MIMO enhanced ICIC and release was introduced in the release 10, which is the LTE Advanced. In release 11, the 3GPP had given enhanced carrier aggregation with an additional feature of interband carrier aggregation. These are the four different releases given by 3GPP towards the specification of LTE. பார்த்தா சார் உங்களை வந்து பார்க்க சொல்கிறேன். So these release 8, release 9, release 10, release 11 are the four releases given by the third generation partnership project towards the specifications for long-term evolution. Let us see how they had done this with their time schedule. The LTE Advanced Workshop was conducted during the start of 2008. Then they had sent a circular letter to the ITU. Then the ITU did the study. Then in between they had sent proposals, they had did the evaluation, and they had submitted the data to the IMT Advanced candidates for the evaluation. Then after evaluation, the final submission was done during the later half of 2009. Then after final submission evaluation, they had started their working from 2009 till 2010 mid. They worked on the item. Then the specifications was being finalized. After the specifications was finalized, they completed it. Then the LTE release 10, LTE Advanced was being released. So similarly, the IMT Advanced standard was given within the same period. So at the starting of 2011 March, the LTE Advanced and the IMT Advanced standard was being released parallelly. So this is the time schedule. So next topic is the third generation evolution towards fourth generation 3G evoluting to 4G, how it came. So the first release of WCDMA radio access that was developed by the RAN group, technical specification RAN group, was released to contain some of the requirements of the IMT, International Mobile Telecommunication 2000 requirements as defined by ITU. This included circuit switched voice and video services with the data services over both packet switched and circuit switched bearers, both the systems. The first major addition to the radio access feature to the wide band code division multiple access, or the WCDMA, is HSPA, which was added in the release 5. So this HSPA stands for High Speed Downlink Packet Access. And with the evolution of enhanced uplink, so this HSPA is only meant for downlink, high speed downlink packet access. So this was upgraded to uplink also. So in the release 6, these two systems were together called as HSPA. So with HSPA, UTRA, that define the definition of the 3G mobile systems, also contained the broadband mobile data. So So this evolution continued in 2004. So when a workshop was organized to initiate the work on the third generation partnership project called Long-Term Evolution Radio Interface, is LTE, after 3G. So as a result of the LTE workshop, which had a study item in third generation partnership project, technical specification group, radio access network, created in December 2004, the first 6 months were spent on defining the requirements, such as the data rate, the complexity of the architecture, the spectrum utilization, the intercarrier interference, the channel bandwidth, and so on, which are the design targets. And these were being documented in a third generation partnership project technical report and was approved in June 2005. So most notable are the requirements on high data rate at the cell edge and the importance of low delay in addition to normal capacity and peak data rate requirements. Further, spectral flexibility and maximum quality between the frequency division duplexing and the time division duplexing solutions were being announced. And during 2005, the technical specifications group of the 3GPP, especially the RAN group WG1, made extensive studies of different basic physical layer technologies in December 2005, and that group decided to release that LTE radio access, long-term evolution radio access, should be based on OFDM in the downlink and DFT pre-coded OFDM in the uplink. Extensive study was done by them, and they had proposed that to use orthogonal frequency division multiplexing in downlink and discrete Fourier transform pre-coded orthogonal frequency division multiplexing in the uplink. So the reasons for this were being discussed, and the RAN group and its working groups then worked on to the LT specifications, and they were success, and the specifications were approved in December 2007. Thus, what we are seeing nowadays is your LTE. So if you are having any queries till this topic, you can type in chat box. The evolution of 3G to 4G. Any queries? If you're having any queries, kindly type in chat box. I'll give you some 4 or 5 minutes of time. Any queries, please type, or else we'll move on to we'll move on to the next topic. Okay, since I couldn't find any queries in chat box, we proceed on to the next topic, which is based on LTE Advanced. So this IMT Advanced was being developed by the ITU, International Telecommunication Union, that came into existence. That came into existence during 2008 in a phased manner. The work on the IMT Advanced within the ITU, International Telecommunication Union, was been started in 2008, and in phases, phase by phase, it came as a circular letter, and then they started triggering the activities in the third generation partnership project, where a detailed study was being done on the long-term evaluation advanced system. So the task was to define the basic requirements needed, as we had seen in the standardization of LTE, investigate them as per the requirements, evaluate them with the existing specifications or add new specifications, then evaluate it. So this task was being defined. So the work was turned into an work item in 2009 in order to develop the detailed specifications. So within 3GPP, LTE Advanced was seen as the next major step in the evolution of LTE. So the LTE Advanced is therefore not a new technology. It is an evolutionary step in the continuing development of LTE. So with the wider bandwidth through aggregation of multiple carriers and usage of evolved advanced antenna techniques, both in the uplink and downlink, the major components that were added in the release 10 of LTE, which reached IMT advanced targets. So the work on the LTE advanced within 3GPP was planned with the ITU or within a time frames. The next topic that we are going to see is the EU-tron. So, EU-tron stack. So, EU-tron is the air interface of the third generation partnership project. long-term evolution which was upgraded for the mobile networks with the existing one. So the EUTRON stands for Evolved UMTS Terrestrial Radio Area Network, so Radio Access Network. Evolved UMTS Terrestrial Radio Access Network, which is a combination of the EUTRA, which is handling the user equipment, and the EUTRON Node B, or the Evolved Node B, which you can shortly write as E Node B. Okay. So this evolved UMTS Terrestrial Radio Access Network uses the orthogonal frequency division multiple access modulation technique for the downlink, and the single carrier frequency division multiple access for the uplink. So officially, this UTRON governs the base station, where EUTRA without N defines the mobile side, mobile device side. If N is present, it is the entire network, and if N is not there, it defines only the mobile device side. So this UTRON is a parallel to the work on the radio access technology in a third generation partnership project, where the overall system architecture of both the RAN radio access network and the CN core network was redefined depending upon the functionality between the two network parts. So this work was also known as the SAE, System Architecture Evolution, that resulted in a flat RAN architecture as well as a new core network architecture which was referred to as EPC, Evolved Packet Core. So together the LTE RAN and the EPC can be referred to as the same EPS, Evolved Packet System. The RAN is radio access network, or the RAN is responsible for all radio related functionality of the overall network, including the scheduling, radio resource handling, retransmission protocols, coding, and various multi-antenna schemes. The EPC is responsible for functions that are not related to the radio interface but needed for providing a complete mobile broadband network. The mobility management MME is the control plane node of the EPC, which is responsible for a connection or release of bearers to the terminals, handling of idle to active transitions, the handling of security keys. The major functionality operating between the EPC and the terminal is sometimes referred to as non-access stratum, or the NAS, and it is separate from the access stratum that handles the functional operating between the terminal and the radio access network, or the RAN. The servicing gateway, or the SGW, is the user plane node that connects the EPC to the long-term evolution radio access network. The serving gateway will act as a mobility anchor when the terminals move between E node BS, that we'll be seeing in the next unit, E node BS, E node at the base station, as well as the mobility anchor for the other third generation partnership project technologies like the GSM, GPRS, and the high-speed downlink packet access network. So the collecting of the information and statistics are very much necessary for charging, which is also handled by the servicing gateway, or the SGW. So next, what we are going to see is the Pdn Gateway, or PGW. So PDN stands for the Packet Data Network. The PDN gateway connects the evolved packet core to the internet, where the allocation of the IP addresses for a specific terminal is handled by the by this Pdn Gateway or the PG Gateway, which is specified as PGW, as well as quality of service, which is enforced according to the policy controlled by the PCRF. So the PCRF stands for the Policy and Charging Rules Function. So this PDN gateway is used as a mobility anchor for non-3GPP radio access technologies such as CDMA 2000 that connects the evolved packet core. So in addition, the evolved packet core also contains other types of nodes such as PCRF, which is your Policy and Charging Rules Function, that is responsible for the QoS, or the quality of service, handling charging in the home subscriber service nodes. So which is the HSS, which is a database that has only the subscriber information. There are also some additional nodes present in regard to the in support of the multimedia broadcasting services. They are the MME, the mobile mobility management, the PGW, packet data network gateway, and the service gateway can also be used as a combined structure into a single physical node. So this shows how. The next is a diagram which shows how the EPC network of evolved packet core network is being interfaced into the radio access network interface. You can see from the diagram. We have first let us see the core network architecture of an evolved packet core. So this consists of a internet. From internet it is connected to the radio access network through PDN gateways, then to the service gateway, which is being managed by the MME, mobile mobility management equipment. So where this MME is stored in an home subscriber service. So in this way, it is being connected and it is being deployed. So from this core network architecture, how the radio access network is being interfaced, that you can see in the second diagram. So we have a service gateway, we have a mobile mobility management equipment, MME, for two different users. We have a E node B, which is the base station, two E node Bs, which acts as a base station, and one center, which is E node B. So their accession is through switches S1U from E node B to service gateway, and from MME to the E node B. The switch is S1C. So depending upon the application or the requirement, this radio access network can be interfered with each other. Somebody wants to join in the meeting named Likita 2000. Inform Likita to join using their official email ID. Let us see a demonstration on how this E evolved node B and the MME in Utron is being present. Let us see an animation towards that.
Of EUTRAN. The key element, one of the major element that is present in EUTRAN is nothing but ENB, which stands for E node B. The main responsibility of E node B would be, as we discussed, it is radio resource management. The functionality of radio resource management includes maintaining, allocating the resources, transferring and communicating E, uh, with the UE for effective communication over the wireless channel. Then comes synchronization and interference control. Synchronization includes here both time and frequency synchronization. And then comes MME selection among the MMA pool. There will be a set of MMA pool that is allocated to a particular area, and the job of this E node B would be choosing one of the MME among the available MMA pool. Then comes routing the user plane data from and to software gateway. As we have seen previously, all the cultural channeling signaling happens with MME from eNode B, and the user plane or user data communication happens with S gateway, that is serving gateway. Then comes encryption and integrity protection of user data. Encryption of the data of what UE sends to base station, and integrity protection means identity protection kind of things will happen in eNode B. Then IP header compression. These are the main jobs in which eNode B is involved in. The communication between serving gateway and eNode B happens via S10 interface. Interface is nothing but a set of layer of protocols from layer 1 to layer 4 or whatever the standard that supports for that interface. So S1 is the name of the interface that is being used for communication of eNode B with EPC, that is the evolved packet core. So the kind of interface is here is a many-to-many interface. Like one eNode B can be connected to multiple MMEs as gateways, whereas and one S gateway can be connected to multiple eNode Bs. This S interface can be split into two categories based upon the type of data that is carried between the network elements of EPC and network elements of EUTRAN, that is eNode B. So as we said before, this all the user plane data that go will be going on from eNode B to software gateway. So this is called as S1U interface. All the data that is going to the control plane from eNode B is towards MME, that is mobility management entity. So that is called as S1C interface. So the main purpose of this particular interface, or the main purpose of this communication between these network elements, is for network sharing, redundancy, and load balancing. There is one more interface present in this particular aspect, that is X2 interface. X2 interface is used for communication between two eNode bits. This is one of the interface which is not present in any other previous networks. This is the new interface which is present in LTE. It is actually used for inter eNode B handover, load balancing, and interference management. When a UE is moving from one cell to other cell, or when the call is getting transferred from one eNode B to eNode B, this particular interface can be utilized for communication between two eNode Bs. But still, the mobility is governed. We have to keep in mind that, but still, the mobility is governed by the MME entity. Now let us look the look into the elements that are present in the EPC. So let's first see mobility management entity. So mobility management entity is one of the key entity. As we said, it governs all the it governs all the control plane data that is coming from B node B. So the most of the jobs of MME would be involving in the control plane of the network. So the main functionality would be like, let us see the functionalities of this MME. The functionality, first functionality is it governs NAS signaling and its security. NAS stands for non-access stratum. This non-access stratum lies above the LTE protocol stack, and the signaling between NAS and core network happens with MME. Access stratum security control is one of the key functionality of mobility management entity as well. So access stratum involves the layers below the NAS, non-access stratum. Those are actually LTE protocol stack. We will see the LTE protocol stack in the coming slides. And one more functionality is tracking area list management. I mean, as we discussed previously, each MME or MME pool is responsible for certain area that we call it as tracking area. So MME is responsible for tracking the location of UE and update accordingly. So that we call as tracking area list management. PDN gateway and serving gateway selection. So what is the serving gateway that the UNODB has to communicate it to be from user from EUTRAN is governed by this MME. So MME selection for inter MME handover is also by handled by MME. So when a UE is moving from one tracking area to other tracking area or one area to the other area which is in the realm of other MME, the next MME which has to be selected is also governed by the current MME. Roaming and authentication is also one of the roaming and authentication is also one of the tasks of this MME. EPS bearer management. We'll see what is an EPS bearer. Basically, an EPS bearer is a bearer through which the complete user data transfer is traveled from various layers. We will see what is an EPS bearer. EPS stands for Evolved Packet System. So signaling for mobility management between 3GPP radio access networks is also gone by MME. Now we will see Now, let us see the interfaces that MME use for communication to communicate with various other entities. The first one is S10 interface. S10 interface actually is used by MMEs to communicate with other MMEs to update various details when UE is in when UE is in mobile and it is moving from one MMEs to other MMEs. And S11 interface. S11 interface actually supports EPS bearer management between MMEs and S gateway. As we have seen before, MME is used for managing this EPS bearer as well. EPS bearer is the bearer which carries all the user data. So MME communicates with serving gateway to through this S11 interface for EPS bearer management. Then comes S6A interface. S6A interface is used to communicate with HSS, which is home subscriber server, where all the user data is resides. It can be compared to the HLR of UMTS networks or GPRS and 2G networks, where all the data related to user is present there and it is used for the user authentication.
Is there any other queries? Narsimha is available. CR Narsimha is there.
Yes, sir. Sir.
When did you reach your home?
Sir.
After your passport verification, when did you reach your home?
Not verified, sir. Passport till now.
But your sir said that you are in the passport verification office, some issues. Solved or not?
Yes, sir. Solved, sir. Actually, the 10th certificate is mandatory for passport verification, sir.
Yes, yes. SSLC or 10th standard is mandatory, or
Yes,
else
sir.
it
Yes,
will not be processed.
sir. Till now, I didn't apply for passport, sir.
Apply it soon. You might be required during your placement sessions.
I want to change my Aadhaar card, sir. Name.
Oh, name change in Aadhaar. Okay, okay.
Sir. SSC certificate, Aadhaar card should be same, no, sir. That's
Yes, it should
why.
be same. Your PAN number, your PAN card number, your Aadhaar number, and in your passport, everything
That's
should be
why I
same
applied to
name.
change that, Aadhaar card, sir.
Yes, everything should be same. Then only it will be processed, or else
Sir.
they'll put you in backlog. So, any other queries for this session? You can type in chat box. So, these are the references. Eric Dahlama and Stephen Parkwall, John Scold. All these three authors combinedly wrote the 4G Lte Advanced for Mobile Broadband, second edition. So, the referred textbook as well as my reference. Eric, the same author, Eric Dahlma, Stephen Parkwall, and John Scold. They had upgraded from the second edition to the third edition by writing the textbook called 4G, LTE Advanced Pro, and the Road to 5G. Third edition, you can refer that. And another textbook that I referred is an introduction to LTE, LTE Advanced SAE, and 4G Mobile Communication by Christopher Cox, John Woolley Publications, 2012. So these are the references for Unit 1. So any other queries, you can kindly type in chat box. We will have a discussion, then we will proceed on to the next topic or the next session. So if there are no further queries or no discussions or discussion forum is empty, so you can fill the attendance link for today's session, which will be active till 11:55. Only the students, those who fill this form, will be given attendance. The attendance for today's session is given in chat box. Kindly check it. I request everyone to use their official email ID while giving your attendance in the feedback.